we are going to be looking at the chapter for revision. Let's take a look at the first couple of problems. Problem number 1. Color arcs to show the decimal. So here we have 0.2. This 2 is in the 10th place, so that means it's 2 out of 10. So 2 out of 10 would be if I split this into 10 equal columns and I color in 2 of them. So that's 2/10. And then 4 hundredths, this 4 is in the hundredths place. So we have a 0, 4 in the hundredths place, that's 4 out of 100. And so we'll color in an additional 4 blocks out of 100. So this is equal to 24 hundredths. Next, we have this. We have 9 hundredths. We have a 9 in the hundredths place and a 5 in the hundredths place. So we'll do the 9 in the hundredths place. Maybe I could try using different colors for them. And yeah, I'll use orange for this one too. Whoop!
Orange for Scipio.
Scipio the orange. Yep. Okay, so I'll use orange for my second color. So here we had 4 over here.
Wait, did Carthage make up the color purple?
No, they just sold it. And we have 5 hundredths there for a second color. Great. So that's our orange. Okay. Here we just have 7 hundredths. We could go ahead and write that 7 hundredths as a, well, 7 in the hundredth place. So we look at the hundredth place, not the 10th place. So 0 in the 10th place. And here's 100th place, so we'll put a 7 in the 100th place. Great, and so that is just 7 individual blocks. 7 in the 100th place is equal to 7 out of 100. So we split it into 100 equal pieces, and we fill in 7. Great. This one is 6/10. This is in the 10th place, and so it's equal to 6 out of 10. 6/10, the decimal is equal to the fraction 6 out of 10. So if we split into 10 equal columns, and there's 10 here, we'll fill in 6. 1 column, 2 columns, 3 columns, 4 columns, 5 columns, 6 columns. Okay, great. Next, we have write in expanded form. So we just write each place value. So we have is equal to 0 ones plus, we have a 4 in the 10th place, so that's 4/10 plus, we have a 9 in the 100th place, so that's 9 hundredths. Plus, we have a 5 in the 1,000th place. So that's 5 thousandths. That's what you do for that problem. Next, 2.67 or 2 and 67 hundredths is equal to 2 whole plus 6/10 plus 7 hundredths. Great. Next, we have write the decimal indicated by the arrows. Okay, so take a look here. We have 0.04, 0 and 4 hundredths, and then here we have 0 and 6 hundredths. So we know between here is going to be 0 and 5 hundredths. And then how do we know what each of these specs are? Well, we know that there are 10 lines in between each of these hundredths. And so 10 times smaller than hundredth is?
1,000.
Correct. 10 times smaller than hundredth is thousandths. So thousandths. So we know that this is a 10th of 100 to the right of 4 hundredths. So it's not quite 400th. It's a 10th more than 400th. And a 10th more than 100th is a 1,000th to the right of it. There are 10 thousandths in 100th. So 1 to the right of this 100th is 1,000th. And then 2 to the right of it, this one here, is, it's not just 400th, it's 400th plus 2 out of 10 to the right, which is 2,000th. So that would be our answer A, 0 and 42 thousandths. And we say 0 and 42 thousandths because the last number in this, the last digit in this number is in the thousandth place. Great. And then let's take a look at this B. How about we work backwards for this one? So we could start at what we know. We know that the C has to be 0 and 500th. And we know the C is 0 and 500th because it's directly between 0 and 400th and 0 and 600th. Great. And so what if we want to work backwards? So we are going from 0.05, and we're counting down 1, 2, 3 hundredths. Well, we can imagine a 0 after this 5, right? Because we're going to be taking away thousandths from this 500th, right? So we're trying to find b, and we know that it's 3 thousandths less than 500th. And so we can actually we can do the math here, right? We know it's, whoops, 500th, my bad. Boop, doop. So we know that it's 3 thousandths, 3 ticks, 3 thousandths less than 500th. So we could do this, and that would tell us our answer. Or we could also kind of just do it in our head and see if we have every 100th has 10 thousandths. So when we see this as 0 and 500th, we can also see it as 0 and 50 thousandths. That's the same number. 0 and 500th is the same as 0 and 50 thousandths. And it's a lot easier for us to do 0 and 50 thousandths minus 0 and 3 thousandths in our head than 0 and 500th minus 0 and 3 thousandths. Can you guys do 0 and 50 thousandth minus 0 and 3 thousandth in your head?
Yeah.
0 and 50 thousandth minus 0 and 3 thousandth in your head is 0 and 47 thousandth. It's 3 ticks to the left, and we know that there are 10 of these ticks in every hundredth. And so we're trying to figure out what 3 out of 10 hundredth less than 500th is. So we know that this tick here is 0 and 500th, or 5 out of 100, and we want to know what 3,000th less than that is. Each of these ticks is 0.001, 0.0010, right? And so, yeah, that's what we did. So let's take a look at D. So this one, let's do that example again where we have a higher number and we find one before it. So we're going to start at one that we know, 0 and 600th. And this one's, we're trying to find D, right? So I'll do it over D. 0 and 600th. And how much less are we going? We're going less because we're going to the left. We're going smaller.
There are 5 ticks in between D and 6.
Yeah, so we have 1 tick, 2 tick, 3 tick, 4 tick, 5 tick. Correct. There are 5 ticks between 5 ticks less than 600th. And so how do we know how much each of these ticks are? So it's going to be 5 times the length of each tick. And each tick is 1 thousandths. And the reason each tick is 1 thousandths is because there are 10 ticks between each hundredth. And there's going to be 10 hundredth ticks. There's going to be 10 hundredth ticks between each tenth. And if you have 10 tenth ticks, then you have 1 whole. So we know that each of these ticks are thousandth ticks because there are 10 between the hundredth. Great. Okay, so we have 0 and 600th minus, and we're going back 5,000. 0.005. 5,000. And so, like I said, it's easier to do, instead of doing the math in our head that is, oh, can you do 600th minus 5,000? No, that's a bit hard. But 600th, you just remember that 600th is equal to 60,000th. And so it should be easier to do 60,000th 60,000th minus 5,000th in your head, right? 60,000th minus 5,000th is 55,000th, right? You could kind of do that in your head because they're in the same like place, right? And so you just kind of want to try to remember that trick that if we have 600th, well, we know that there are 10 groups of hundredth, or there are 10 groups of thousandth in a hundredth. And so when I'm looking at 600th, 600th is equal to 60,000th. Just like if we're looking at money, and if I have 0.1 of a dollar, 0.1, that's 1/10 of a dollar, which is a dime, and 0.1/10 of a dollar is also equal to 0.10 hundredth of a dollar, which is equal to 10 cents. You guys see that? 0.1 is 1/10 of a dollar, which is a dime, and 0.10, which is still a dime, is equal to 10 cents. It's equal to 10 hundredths. Make sense? Okay, so for this, we'll do, we find out that D is 5,500th. And then we look at E, and so E is just 2,000th. Oh, I'm sorry, D was 55,000th. Whoop. E is just 2,000ths more than 600th. So just 600th, and then plus 2,000th. We'll just add a 2 in the thousandths place because we went over plus 2. Okay, next we have compare using less than, equal than, and greater than. So what is greater, either 2,500th or 215 thousandths? That would be 2,500ths. All you do is you compare. So what is bigger? We compare from left to right. What is bigger? The ones place? Oh, they're the same. Okay, what is bigger in the 10th place? Oh, they're the same. What is bigger in the 100th place? Oh, this 500th is bigger than 100th, so it's bigger. Okay, what about this? Ones place are the same. 10th place? Oh, 3/10 is bigger than 1/10. 3/10 is bigger. What about this? 4? Oh, they're the same. Okay, 0/10. Oh, 3/10 is bigger than 0/10. So 4.33 or 4 3300th is bigger. 0.65 or a half. Oh, this is a bit tricky. How can you do this? Well, if you don't remember what 1/2 is into decimal, we can just find out. We do the top number divided by the bottom number. 1 divided by 2. That's what 1/2 means. It means 1 divided by 2. 2 goes into 1, can't do that. Drop the 1. Okay, now we do decimal 0. 2 goes into 10. Wait, whoop. Yeah, 1 minus 1 is 0. There you go. 2 goes into 10. Oh, drop.
5 times.
Yes, 2 goes into 10 5 times. 5 times 2 is 10. Perfect. Remainder 0. And so 2 goes. Oh, we have to remember one thing. What did I not do yet?
You didn't move the decimal.
Great, yeah. So 2 doesn't go into 1 5 times. I raise the decimal straight up. 2 goes into 1 0.5 times, or 5 out of 10 times. Great. Okay, so 1/2 is equal to 0.5. And if you guys want to find out what a fraction is as a decimal, that's what you do. You do the top divided by the bottom. So what's bigger, 0.65 or 0.5? Well, let's find out. 0, 0, those are the same. 6/10 is more than 5/10. So 6/10 is bigger. That gets the greater than sign. Okay, what about these two? 0, 0, oh, they're the same. Up, here we go. 2/10 is greater than 0/10. And so 2/10 is greater. Right as decimals? Oh, we were kind of practicing this. This is 3 out of 100, so we should have a 3 in the 100th place. This is 48 out of 1,000. Yeah, so what we're going to do is we can kind of set up our number, ones place, decimal, 10th place, 100th place, 1,000th place. And I know the last digit is going to be, in the 1,000th place. And then we write the number backwards from there. So we have the 4 here, and then we just fill in 0 for everything else. There we go, that's 48 thousandths. Okay, we have a 1 in the ones place. And then, this is the decimal to the right of the decimal. We have a 209 thousandths. And so we are going to have 3 place values, 10th, 100th, 1,000th. And we'll start at the thousandths place. And we'll write the number on top, starting from the thousandths place to the left, kind of like backwards. 902. See that? So this number is 1 and 209 thousandths. And this is the last one. This 3 is a whole number, so it's going to go in the ones place. 3 point, and we have 39 out of 100. So it's going to be going to the 100th place. We'll stop at the 100th place, and then we'll write the top number backwards. 9, 3. We're not writing it backwards. We're just writing it from right to left instead of, well, not backwards. Okay, question number 6. Write as fractions or mixed numbers. Oh, does anyone remember how we do this? Raise your hand if you remember. Yeah. I see Estelle's hand highest.
I don't really know how to like explain this, but you look in the last digit of the decimal, and that's the denominator, and then
Yep,
you just
and
put
so
the number on top.
So what would be for 1 3/10? What would be, what would I look at for this 3 in the 10th spot? 3, almost. I'm not looking at the 3. I'm looking at.
I'm at 10. I'm at 10. I'm at 10.
Yes, this 3 is in the 10th place, which means the whole thing is over 10. So I'm going to have a 10 at the bottom because it's in the 10th place. Great. Does someone else want to raise their hand? Maybe Chase, can you answer? So what number goes on top now?
3.
Not just 3. I mean, you could. That would be one answer, but
Yeah.
I'm doing it mixed number. What?
There's a hole. One hole and.
Oh yeah, sure. So yep, you're absolutely giving a right answer. So I could do one whole number and 3 out of 10. That is how you would write it as a normal fraction. Another way I could do it is out of 10, and then on top I would write the whole number, the entire number, without a decimal. So in this case, I'd write 1.3 without a decimal, so 13. 13 out of 10 is equal to 1 whole and 3 out of 10. Great. And that's because 13 divided by 10, how many times does 10 go into 13? It goes in 1 whole time and 3 out of 10 times. Does that make sense? If I wanted to go 13 divided by 10, calculator. 13 divided by 10. If I have 13 pizzas that I want to give to 10 friends, right? How many pizzas will each person get? If I have 13 pizzas that I'm giving to 10 friends, each person will get 1 pizza and 3 slices out of a pizza with 10 slices. So that's what this problem tells us. Okay, let's keep going. 0 and 8,000. So we look. The last numbers are the last digits in the 1,000th place. So we'll write 1,000 on the bottom, and then we write the easier way to do it. And we're just doing mixed numbers, so luckily we could do that. Is write the whole number without a decimal on top. So 0, 0, 0, 0, or 0, 0, 0, 8 is the same as just 8. Okay, and then this number is 2 and 1,500th. This 5 is in the 100th place, so we'll have 100 on the bottom and write the whole number on top without a decimal. So 215 divided by 100. And great, another way we could write this is instead of writing like this, if we wanted to write it as a fraction, we would write the whole number on its own, 2, and then just write, just kind of solve the decimal kind of as if it was on its own. Kind of like if we're solving 2 plus 1,500th. And we could just solve the 1,500th like normal. We would just look at the last one in the 100th place, so we'll write 100 on the bottom, and then 15 on top with no decimal. Boom, and that's how we do it as a normal fraction. See, not too much different. So for this one, we just look at the last place is the 1,000th, so 1,000 on the bottom, and then we write the number on top without the decimal, 38. Woo! Page 1 done. I'm going to take a little break. Great, on to the next page. So we have the problem, round the numbers. So in order to use this, I'm going to write all 10 digits of our amazing base 10 number system. Great. It's pretty cool. We've been using it for a while. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Wow, would you look at, we have 10, wait, not 10. What is 10 doing there? Just kidding. We only have 10 digits. And so our first digit is 0. And our second one is 1. And our third one is 2. And our fourth one is 3, 4, 5, 6, 7, 8, 9. So we have a total of 10 digits. So we can kind of split them in our head. And we can think of them as less than 5 and not less than 5. So it's either less than 5, right? And this is half of the digits, 0 through 4, or not less than 5, and it's either 5 or greater. And so see, each one has 5. So half the time it'll go down and half the time it'll go up. Great. And so basically this is what we do when we're rounding. So round the numbers to the nearest 1, nearest 10th, and nearest 100th. So we are going to be rounding 4 and 608 thousandths to the nearest 1. So we're going to underline the ones place, look at the one to the right, circle that number is what I always do, and then see, is this number on this side or this side? Or another way you can think of it is if the number is less than 5, round down. Otherwise, round up. Just write that. If the circled number is less than 5, round up. Else, that's how we say it in coding. Else, round down. Wait, if the circle number is less than 5, whoa, I got that backwards. If the circle number is less than 5, we round down. Yes, if the number is 0, 1, 2, 3, or 4, we'll round down. Yep.
Everyone is Team Row now.
Okay. Please focus on the assignment. Else, round up. Okay, so if it's one of these numbers, we'll round down. If it's one of these numbers, we'll round up. And actually, so if you guys remember, if round down, you know what we do?
The number stays the same and all the numbers to the right become 0.
Yep, all numbers to right of rounded. I'll just write the number sign, the pound sign number become 0 if round up do the same except add 1 to rounded place. Yeah, rounded place value. You know, I'll just say rounded number. Woo! Okay, so 4.608, and we're rounding to the nearest 1, so 6 is 5 or greater, so we're going to round up. So we're going to add 1 to the place we're rounding to, which is the ones place, and then turn everything to the right to a 0. So we can just write that as 5. Next, we're rounding to the 10th. So we have 4.608 rounding to the 10th. So underline the 10th, look at the number to the right. 0 is less than 5, so we're going to round down. Keep the numbers the same, except everything to the right turns into 0. So we don't even have to write it, because it all turns to 0. So we just don't write anything after the place that we round to. And then the nearest hundredth, 4.608. So we look at the 100th. Yep, and so we look at the number to the right, the 8, that's more than or equal to or more than 5, so that's going to become a 1, 4.61, everything to the right becomes a 0. Do I really have to do all of these? I'm going to start doing them in my head. 23, so we have the 3 is going to round down because of the 1, so we just get 23. 23.1, we're going to look at the number to the right. 0, we're going to round down, so 23.1. And then when we round to the 100th place, we're going to look at the 9. We're going to round up, so we're going to add 1 to the 100th place, 23.11, right? Because we added 1 to the 100th place. We're rounding. Okay, here we're rounding to the ones place again. 2, we look at the 2 in the 10th place, which is less than a 5. So we're going to round down, so it just becomes a 2. When we round to the 10th place, we look at the 2 in the 10th place. Look at the number to the right. There's a 9 there. That means we're going to round up, so the 2 in the 10th place becomes a 3 in the 10th place. So 2 and 3/10. And then for the 100th place, we have a 9 in the 100th place. We're going to look at the number to the right, which is also a 9. that means we're going to round the 100th place up. And so the problem is, and I can write this out because to make sure we can all see it, we're rounding to the 100th place. We look at the number to the right. Great. This 9 here in the 1000th place means we're going to round the 100th place up, but when we add 1 to the 100th place, it becomes a 0, and so this 1 is instead going to be added to the place over, the 10th place. And so when we add 1 to the 10th place, it becomes a 10, right? And so we're going to have a 0 in the 10th place and add 1 to the 1st place.
Isn't that supposed to be a 2?
Where?
This number, isn't it supposed to be a 2?
Oh, did I actually, this one? Yep, did I actually turn it into a 9? Whoops. Yep, absolutely correct. So that means this would be 299. This 2 would become a 3. And so the answer would be 2.3. Is that what you guys got? Good. If you guys see any discrepancies, call it out, because that's good. Okay, perfect. So now we have the number 0 and 4800th, then we're going to be rounding to the nearest ones place. We look at the number to the right, which is a 0, which means we round down. 0, nothing happens to it, so we have 0. Next, we have 0 and 4800th once again, but we're rounding to the nearest 10th place. We look at the number to the right. 4 is less than 5, which means that we're going to round down. We round 0 down. It's going to be 0.0, which is 0. Great, kind of. And then now we're going to round 0 and 48,000th to the 100th place. And so we look at the number to the right. 8 is equal to or greater than 5. So we're going to round 4 up. We add 1 to it, make everything to the right 0. 0.05 hundredths. Great. Got through, 5 hundredths. Got through all of that. Okay, next we have add or subtract. And so if you guys remember, for these problems, all we need to do is, I might just go ahead and erase a little bit of this. For these problems, all we need to go ahead and do is add and subtract normally, except we make sure to line up the decimals. Great. Okay, so 0.3 tenths. We're adding that to 0 and 5,000th. And here, just take a look just to refresh your guys' mind. 0 and 3 tenths is equal to 0 and 300 thousandths. Those are the same because there are 100 thousandths in every tenth. Okay, so 300 thousandths plus, yeah. So 5 plus 0, and see, we drop the decimal straight down, easy peasy, hopefully, as long as you remember the rule. 0, 305 thousandths. Next, 0 and 300th plus 0 and 5 tenths. And so 0 and 5 tenths is equal to 50 hundredths, because 5 dimes is equal to 50 cents, right? So 0 and 5 tenths, a dime is a tenth of a dollar, and so 5 tenths is equal to 50, just like 5 dimes is equal to 50 cents. So we have, so this problem is basically like adding 3 cents plus 50 cents, which is 53 cents. And drop the decimal. Okie dokie. Man, we're kind of running out of room here. Okay, so now we have some subtraction problems. 0 and 9 tenths minus 0 and 7 tenths. We can imagine this is money once again, a lot with decimals. 9 dimes minus 7 dimes is 2 dimes. Or we just do it like normal. 9 minus 7 is 2. Drop this decimal. Great. Okay, next we have 0 and 9 tenths minus 0 and 7 hundredths. And so the 0 and 9 tenths, the 9 dimes is equal to 90 cents. So 0 and 90 minus 0 and 7 hundredths. 0 minus 7, can't do that. Take from this. 3, 8. Great. 83 cents or 83 hundredths. 83 cents is 83 hundredths of a dollar. Okay, great. Man, I'm kind of running out of room still. 0 and 8 thousandths plus 0 and 9 tenths. And 0 and 9 tenths is equal to 0 and 900 thousandths. And 0, and this one is just 5. And so I could just write 5 with zeros and everything after. So guys, one thing I want you guys to know is adding a bunch of numbers at the same time is fine, and we're only doing 3, so it's not a big deal, but subtracting a bunch of numbers like this one, just do it one at a time. Don't do them all at the same time. Okay, 8 plus 0 plus 0 is 8, 0 plus 0 plus 0 is 0, 0 plus 9 plus 0 is 9, 0, 0, 5 is 5, drop the decimal straight down, and that's your answer, 5.908 thousandth. Okay, another adding problem, 0 and 9/10, 0 and 8/10, and 0 and 17/100th. So 9 dimes plus 8 dimes plus 17 cents. 9/10 is equal to 90/100th, and 8/10 is equal to 80/100th. 0 plus 0 plus 7 is 7. 9 plus 8 is 17 plus 1 is 18. Great. And then 1 plus 0 plus 0 plus 0 is 1. Drop the decimal, 1.87 or $1.87.
Huh? Oh, I did it wrong. I put a 6.
Oh, that's all right. We all mess up sometimes, just like I messed up earlier. So we have 2.5 minus 1.02. So remember, this whole time we're lining up the decimal. 2.5, or 2 and 5/10, is equal to 2 and 50/100th. Okay, so 0 minus 2 is, can't do that. Make this 4, make this 10, make this an 8. 10 minus 2 is 8. 4 minus 0 is 4. 2 minus 1 is 1. Drop the decimal. 1 and 48/100th. Okay, this is the one I said do one at a time. So we're going to do 7.8 minus 0.9 first. And then after that, we'll do minus 0.04. Okay, so 8 minus 9, we can't do that. Okay, and this one we're going to do a 9. And 6 minus 0 is 6, and drop the decimal. And then now we're going to do 6 and 9/10 minus 4/100th. And 6 and 9/10 is equal to 6 and 90/100th. And so 0 minus 4 can't do that. Take from the 9, make it an 8, make this a 10. 10 minus 4 is 6. 8 minus 0 is 8. 6 minus 0 is 6. Drop the decimal. Great.
Mr. Barry, I think you did the bottom of problem C wrong.
Oh, I do this one.
9 plus 8 is 15. It's going to be 1.5. Plus 1 is 1.67.
Oh, so I was right. Okay.
Is it right around here?
Oh.
Well, let's see. 0.9 plus 0.8 plus 0.17. 1.87, right? Or no? Is it that one? Question number C, right?
Wrong? I need to keep on erasing and adding and erasing.
It's all right, though. Absolutely call out if you guys think I'm wrong, because Mr. Barry could be wrong too sometimes, right?
I use purple. I like the color purple.
Carthage. So anywho, let's keep wrapping up. Thank you for the call out, though. It's always good to double check. Okay, so 9A, complete the addition sentences. So I'm just going to do these ones backwards, right? Just like you guys could do. If I want to find out something plus something equals something, I could just do the total minus part will tell me the other part. So I'm just going to do 1 minus 0 and 21/100th will tell me whatever is my last thing that I'm adding. And so 1 is equal to 1 and 0/100th. Great. So 0 minus 1, can't do that. Take from the 1, make it a 0, make the 10th a 10, turn it into a 9, make this a 10. So 10/100th minus 1/100th is 9/100th. 9 minus 2 is 7. 0 minus 0 is 0. Drop the decimal straight down. And our missing answer is 0 and 79/100th. Okay, same thing with this one. We're going to do, so 0 and 4,000th plus something equals 1. So 1 minus 0 and 4,000th will tell us what we added to 4,000th to get 1. And so 1 is the same as 1 and 0,000th. 0 minus 4 can't do that. Take from the 1, make it a 0, make this a 10, make it a 9, make this a 10, make it a 9, make this a 10. 10 minus 4 is 6. 9 minus 0 is 9. 9 minus 0 is 9. 0 minus 0 is 0. Drop the decimal. For this one, we get 0 and 996 thousandth. Okay, here we go. So we have 4 and 391 thousandth plus some number equals 5. So same deal. We're going to kind of do it backwards. 5 minus what will give us what we're adding, right? So 5 minus 4.391 thousandth. Remember to always line up your decimal. You guys see every single problem I'm doing with the decimals, I line up the decimals. And 5 is the same as 5 and 0 hundred, 0 thousandth. 0 minus 1 can't do it. Take from the 5, make it a 4. Make this a 10, make this a 9, make this a 10, make this a 9, make this a 10. 10 minus 1 is 9. 9 minus 9 is 0. 9 minus 3 is 6. 4 minus 4 is 0. Drop the decimal, and we get 609 thousandth. Woo! We still have problems. What? Okay, 10. Find the number that is 500th and 7/10. So 500th, so we can write that as 500th, and 7/10, more than 3.194 thousandths. And so we can add multiple decimals at a time. That's all right. So we have 500th and we have 7/10. What we wanted, I don't want to confuse you, but if you guys want, we could also just, instead of drawing these separately, I could just do 500th plus 7/10 is equal to 7,500th. That might be easier, but doesn't matter. Same answer. So we'll just make sure to add our zeros, because 500th is equal to 50,000th, and 7/10 is equal to 700 thousandths. 4 plus 0 is 4. 9 plus 5 plus 0 is 14. 1 plus 1 is 2, plus 7 is 9. 3 plus nothing is 3. Drop the decimal. And so that would be our answer for 10A. And then let's look at this one. Find the number that is 3 thousandths and 8/10 less than 0 and 902 thousandth. Do I have any room? A little bit.
Let's with the word less and more.
Huh?
They really think that we don't read the problem.
Well, it's because sometimes we don't, right? So anywho, we have 0 and 902 thousandths, and we're taking away 3 thousandths and 8/10. And you know what I'm going to do is, I don't want to subtract. I can't subtract them both at the same time. So instead, I'm just going to combine these numbers. I'll combine these numbers and then subtract it, because it'll actually save me a step. And so what is 3 thousandths and 8/10? How can I take these and put them together and add them together?
803 thousandths.
Yes, exactly, 803 thousandth. And that would save me a step. Instead of doing 902 thousandth minus 3 thousandth minus 8/10, I could just do minus 803 thousandth. Great. And so 2 minus 3 can't do it. Take from the 9, make it an 8. Make this a 10, make this a 9, make this a 12. 12 minus 3 is 9. 9 minus 0 is 9. 8 minus 8 is 0. 0 minus 0 is 0. Great. And so do you guys get that for this problem? 0 and 99 thousandths. Is that what you guys got for that one? Okay. 5 children divided $25 equally, and then each one bought ice cream for $2.05. So choose an expression that matches the problem. Find the exact amount that each child has now. Okay, so we're trying to find an expression for how much each child has now. So to find out what each child has, we would do they had a total of $25 to begin with, and then each of the 5 children get it equally. So 25 divided by 5, that will give us 5 in our head. We'll just remember that in our head. And we know that we're going to do this first before adding and subtract. So we could just put adding and subtract anywhere, because no matter what, this will be done before adding and subtract, because PEMDAS. Okay, so $25 divided by 5 is $5. So each kid has $5, and if each kid bought ice cream for $2.05, to find out what each kid has, you would just do minus $2.05.
So it's number 2.
Yep. And so, find out the exact amount that each child has now. Well, that would just be 5 minus $2.05. We could do that in our head. That's $2.95, right?
That's what I got.
Great. Okay, next we have solve. Oh boy.
Oh, it's multiplication.
I don't want to make this difficult to understand, but this actually might make it easier. So this 4/10 is actually just 4 times 1 over 10, right? We know that because that's how the 10th place works. This 4 is in the 10th place, and anything in the 10th place is times 1 over 10. So this 4/10 is actually 4 times 1 divided by 10. And so this whole problem is actually 4 times 1 divided by 10 times 8. And so we could rewrite that as just 8 times 4 times 1 divided by 10. Do you guys know what 8 times 4 is? 8, 16, 24, 32. 32. Yes, so our answer is just 32 times 1 divided by 10.
I messed that up with 8 times 3, and I'm like, that's 24.
So what is 32 divided by 10? 32 times 1 divided by 10 is just 32 divided by 10. And there's actually a way we could find out what 32 divided by 10 is without doing any real math. We know that the decimals
32
here...
over 10?
What's the decimal trick if we want to divide a number by 10?
You bring it over.
Over to the left or right?
No. Right.
Right will make it bigger and add a 0, making it 320. That's 10 times bigger. We don't want it 10 times bigger. Left. If we move the decimal over 1 to the left, that...
Oh, I thought you meant the numbers, but you meant the decimal.
And so, our answer is 3.2. I'm going to try doing this other one in my head as well.
I did that. I got that.
So 6 times 9, you guys can always just write it on the paper and do it, right? But 6 times 9 thousandths is equal to 6 times 9 times what? If I have a number in the thousandth place, 9 times what? Anything in the thousandth place is times 1 over 1,000. And so 6 times 9 is?
54.
6 times 9, you use the trick, 54. So 54 times 1 over 1,000. And 54 times 1 over 1,000 is the same as 54 divided by 1,000. And so we know in our head how to quickly divide by numbers in intervals of 10. Look, if I write 54, and then I want to just find out where I'm going to put the decimal. If I start the decimal here, I want to do 54 divided by 1,000.
Move it to the left.
Yep, move it to the left, exactly. And the zeros, exactly, the zeros tell us how many times. There's 3 zeros, so we're going to move it to the left 3 times. 1, 2, 3. And so that's where we'll put the decimal, and anywhere that we have to add a 0, anywhere that we skip over. And so our answer is
54 thousandths.
Yes, absolutely. 6 divided by 9 thousandths is 54 thousandths. Great. You guys kind of like solving it like that, sort of? Let's try a couple more. 20 times 5/10 is the same as 20 times 5 times what?
Point.
What value is this in? It's in the what place?
10.
Yes, so 5 times a tenth. Yep, a tenth is 1 over 10. That's what a tenth is, right? If you have a tenth of something, that's 1 over 10. You have a tenth of it. You have 1 out of every 10. So in here, 20 times 5 times 1 over 10. 20 times 5 is?
I got 10.
100 times 1 over 10. And, we could do that 100, and we'll write the decimal. What's 100 divided by 10? We move the decimal to the left 1 time, because there's 1 0,
So
is
we
equal
get
to 10. Absolutely. Okay, let's look at this one. 100 times 3/10. I'm hoping you guys are picking up on the pattern, because this will help you solve it in your head. 100 times 3/10 is 100 times 3 times 1 over what?
10.
Yes, 1 over 10 because the 3 is in the 10th place. Anything in the 10th place is times 1 over 10. Anything in the 100th place is times 1 over 100. Okay, so 100 times 3 is 300. So 300 times 1 over 10 is equal to, what's 300 divided by 10?
300 divided by 10.
30.
Is 30. Yep, we do 300, put the decimal, move divided by 10, move the decimal over once, and we get 30. Okay,
30.
let's look at this next one. 9 times, 2 times what? 9 times 2 times what?
1 over 1,000.
Yep, that's correct. 1 over 1,000 because it's in the thousands place. So 9 times 2 is?
18.
Yep, and then 18 times 1 over 1,000 is the same as 18 divided by 1,000. Well, how do you do that complicated problem? All right, 18 with the decimal after, and then,
Move over 3 times.
yep, and I'd love to hear some more students shouting this out. We're going to move to the left 3 times because there's 3 zeros in 1,000. We're dividing it by 1,000, so we're going to move it over 1, 2, 3. And so you see, we moved over once here, one more time to the left of the 1, so we have to add a 0 there and then add the write the decimal. And so 18 divided by 1,000 is 18 thousandths. Who would have guessed 18 divided by 1,000 is 18 divided by 1,000? That's like exactly what it is. Okay, so 6 times 3 hundredth is the same as 6 times 3 times what?
Times 1 over 100.
Yep, times 1 over 100 because the 3 is in the hundredth place. 6 times 3 is
Mr.
8.
Barry,
Yep, times 1
what
over 100.
about history?
We might have time today. So 18 times 1 over 100, or is 18 times 1 over 100 is equal to 18 divided by 100. And you guys know why that is. If I were to write out...
18.
That's absolutely correct. 0 and 1800. The reason is because if I do 18 times 1 over 100 and I write it out like I'm going to do it, I would do 18 over 1. 18 times 1 is 18. 1 times 100 is 100. So 18 times 1 over 100 is 18 over 100. You guys see that? Or 18 divided by 100. That's what a fraction is. A fraction is the top number divided by the bottom number. Okay, so that is everything on this page. Man, I wonder how much is on this page. Oh, not too much. Hopefully I just go real quick and finish it up. Okay, so divide. Add decimal zeros to the dividend if necessary. Okay, so we might have to add some zeros. So 8 goes into 5 0 times. Ooh, is this too tiny? It might be. 8 goes into 5 0 times. 0 times 8 is 0. 5 minus 0 is 5. Drop the 4.
What's the
8 goes into 54. 8, 16, 24, 32, 48. 54? What do you guys think? 8, 16, 24, 32. 40, 48.
48.
Times.
Closest. Or you can't use 7. It's 56.
6, 8, 16, 24, 32, 40, 48. 54 minus 48. Can't do 4 minus 8. Make sure you guys are following along. 14 minus 8, that's 6. It's 4 minus 4 is 0. Okay, so, this isn't, we don't want a remainder, so we're going to add a 0 and then drop the 0. 8 goes into 60.
7.
7.
7.
Yep, 56, right?
4.
8, 16, 24, 32, 48, 48, 56. Make this a 5, make this 10, 10 minus 6 is 4.
Bring down another 0.
And bring down another 0. And finally, we're going to have something we can use. Who knows this one? 8
It's
goes into 4.
5. It's 5. It's 5.
Yeah,
6, 7,
great.
5.
Perfect. And so when they say check, remember, raise the decimal last step. Great. And then when they say check, they just want you to do 0 and 675 thousandths times 8. 8 times 5 is 40. 8 times 7 is 8, 16, 24, 32, 48, 48, 56, plus 4 is 60. Okay, yeah, we're going to keep going. 8 times, where was I? Was I doing 8 times 6 next? Is anyone paying attention to Mr. Barry? 8 times 6, I
Yes.
think. 16, 24, 32, 40, 48. 48 plus 6 is 54. 8 times 0, I guess I'll know real soon, is 0 plus 5 is 5. And then we have 3 numbers after the decimal here, so we should have 3 numbers after the decimal in our answer. I did something wrong. Let me do that one more time without getting interrupted. 0 and 675,000 times 8. Okay, 8 times 5 is 40. 8 times 7, 8, 16, 24, 32, 40, 48, 56. Right? Plus 4, 60. 8 times 6, 8, 16, 24, 32, 40, 48. 48 plus 6, 54. Ooh, did something go wrong? Did we do something wrong? What did we do wrong? Anyone know? Someone raise their hand.
We didn't do anything wrong.
Obviously something's wrong.
We didn't do anything wrong.
Ah.
675.
And that's because we should be checking what numbers. What numbers should we be checking?
Huh?
What numbers should we be checking?
What do you mean what number should we be checking?
Well, what's wrong? We have 0.675 times 8. 5.4. So obviously. So what's wrong with this then? Anyone know? Come on, students. Anyone know?
I'm confused. There's nothing wrong.
There's nothing wrong.
Then what I'm trying to say is, then what are we checking wrong? What do we need to check in order to make sure that this is correct?
What do you mean?
Everything works, right?
Yeah.
Everything's good? Okay, perfect. Great. Okay, 7 goes into 4. I just want to kind of make sure you guys are paying attention, following along, make sure everything's okay, right? I want some more thumbs up. Okay, 7 goes in 4, 0 times 7 is 0. 4, drop the 4. 7 goes into 44. How many times? Shout it out.
7,
5,
44.
6, right? 7 times 4 is 7 times 6 is 42. Okay, great.
-2.
Add a decimal and a 0 and then drop the 0. 7, 14, we can only go in twice. 7 times 2 is 14. Have a 6.
This is a lot of math.
It's all about the learning. This is going to be what, an 8? That sound about right?
Mm-hmm.
Why is Math Mammoth harder than Eureka?
8, 16, 24, 32, 40, 48, 56. Are you guys following along? Make sure you're double checking. How about this one? 7, 14, 21, 28, 35. Is it going to go even more? How much does this go?
Continues ongoing.
Are you sure? Oh, does it say round your number?
Oh,
It said just go up to 2 decimal digits.
Yeah, so I put 6.28.
Great. Yep. So this would keep going, and so they only want us to go to the round to 2 decimals. So, oh, this is very tricky, guys. So look, our second decimal is in the 100th place. This 8, and so if we look at the number to the right to round, the 5 means we round up. So the 8 is going to become a 9, and so our answer should be 6.29. Make sure you guys.
I got 6.28 because I didn't read it well. Just
Okay,
said
so
the
now
two
let's
best-
double check our answer. 6.29 times 7. And guys, remember, we're not going to get exactly 44. We'll get something close because we're rounding, right? I mean, make sure you write your final answer up here in box at 6.29. That would be your answer if putting out the test. 7 times 9, we can use a trick, 63. 7 times 2 is 14 plus 6 is 20. 7 times 6, 42 plus 2 is 44.
3,
2
0.
decimals after.
I got
Ooh,
a
you
different
guys say
answer. I
it's
got
not
40
exactly 44.
43.96.
Maybe be sure to check your rounding. You have to make sure you round to 6.29 because that's what we're at, right?
No, because I did 2.8.
Okay, so multiply and divide, use the grid. Finally, we have some space. So we're going to have 0 and 614 thousandths
It gives you very little
multiplied by the
space,
number
though.
5. You can just make your own space. Great. And so we have 5 times 4 is 20. 5 times 1 is 5 plus 2 is 7. 5 times 6 is 30. 5 times 0 is 0, plus 3 is 3. And so we have 3 numbers after the decimal in this, and 0 numbers after the decimal in 5. And so we should have 3 numbers after the decimal in our answer. So 1, 2, 3, boop. And so our answer is 3 and 7/100th, or 3 and 70,000. Okay, next we have the number 0 and 79/100th multiplied by 23. You guys see in math, we normally write the longer number, and so you see 0 and 79/100th has, 0 and 79/100th has 3 digits, and 23 only has 2 digits, so I'm going to write 0 and 79/100th on top. No reason, though, but it just looks better, I think. 3 times 9, 27. 3 times 7, 7, 14, 21, plus 2, 23. 3 times 0 is 0, plus 2 is 2. Great. Now we're on to the 2, which is in the tens place, so there's nothing there. 2 times 9 is 18. 2 times 7, 7, 14 plus 1, 15. 2 times 0 plus 1 is 1. Add 7, 11. 1 plus 2 is 3, plus 5 is 8, and then we have a 1. So we have 2 numbers after the decimal in 79/100th and 0 numbers after the decimal in 23. So we add those, and we get 2 numbers after the decimal in our answer. 1, 2, and so our answer should be 18 and 17/100th. Is that what you guys got? Give me some thumbs up if you guys got that. Great, great. Tell me you guys are doing your homework. Oh, great. Now we have a division problem. So
They don't give us a lot of space.
I'm going to tell you guys, so if I'm writing this as, I could write this as a fraction easy. Everyone try writing it as a fraction on your paper right now. You should do it right away. Super quick. 10 seconds, 5 seconds, 4 seconds, 6 seconds, 7 seconds, 2 seconds, 8 seconds. Okay, I'm writing it. I just write the first number, 2.485 over 7. That's how I write it. Done. Okay, so let's actually solve it now. So we have the number, how many times does 7 go into the number 2? Is that a decimal? It is. 2.485 thousandths. Okay. 7 can't go, let me use a different color. 7 goes into 2 0 times. 7 times 0 is 0. 2 minus 0 is 2. Drop the 4. 7, 14, 21 goes in 3 times. 4 minus 1 is going to be 3. 2 minus 2 is 0. Drop the 8. 7 goes into 38. 7, 14, 21, 28, 35. This could be 5 times. We're running out of room. 8 minus 5 is 3. 3 minus 3 is 0. Drop the 5. Ooh, finally, it goes in. 7 goes into 35 5 times. And raise the decimal straight up. And so 7 goes into 2 and 485 thousandths, a total of 355 thousandths times. Correct? Is that what you guys got? Great. And so take a look, students. So this fraction 2 and 485 thousandths divided by 7 is exactly equal to 0.355 thousandths. And so 2.485 thousandths is 35.5% of 7. Okay, and last question. 6 friends shared the cost of a dinner as equally as they could. So equal, that tells us we are going to probably be using fractions, equal. And it's 6 friends. The dinner cost $125.45 in total. Were they able to share the cost equally? How much did each person pay? Okay, so when they said, were they able to share the cost equally, does anyone know what we're trying to find?
how much 6 friends shared equally for a dinner?
Yep, and when they ask were they able to share the cost equally, how do we know if they were or not? How do we find that out?
Divide it.
We divide it, and then what do we look for? Our remainder.
Remainder.
We're going to check our remainder because if we have a remainder, that means they weren't able to pay equally. A remainder means it can't fit into a group, right? If we have 12 candies and we're splitting the 12 candies amongst 5 groups, right? So 12 divided by 5, that's going to be 2 remainder 2. So each group gets 2 candies, and then we have 2 candies that are just like, oh, what are we going to do with this, right? Wait, we're splitting into 5 groups. Yeah, each group gets 2 candies. But I did the original problem again? It doesn't matter. What I'm trying to say is $125.45 divided by 6. If there is a remainder, that means it can't be split equally. There's only a remainder if it's not split equally. Okay, so we'll go ahead and solve that. 120, I'll just do it here for a bit more room. 125.45 divided by 6. So see if there's a remainder. 6 goes into, I'll use blue again. 6 goes into 1, 0 times. 6 times 0 is 0. 1 minus 0 is 1. Drop the 2. 6 goes into 12 2 times. 12 minus 12 is 0. Drop the 5. 6 can't go into 5. 0. 5 minus 0 is 5. Drop the 4. And this would be a 9, right? Yep. 6 goes into 54 9 times. 54. It's looking even. Is it going to be even? Drop the 5. Uh-oh. No, 5. 6 goes into 5. Can't do that. 5 minus 0 is 5. Add a 0. Drop the 0. This isn't looking good. 6 goes into 50. How many times?
Now
8?
8.
8. 8, 16, 24, 32, 40, 48.
Oh, by the way, this is a repeating problem.
We're running into
Good heads
history
up.
This is
time.
a never-ending problem.
This is a never-ending problem, Mr.
Whoa.
Berry.
20,
Take a look.
18,
This is what I would do.
20,
As
18,
soon
20.
as I get past the
Round.
place, yes. As soon as I get past the 100th place, I know, hey, if there's any numbers past the 100th place, if you went up to a store and the store was like, that's going to be a 3,000th of a dollar, please. You'd be like, wait, what? How would you pay with that? Who has 3,000th
And then you
of
give
a dollar?
them a penny, and then they won't give you anything back.
You give them a
A
3 out of 10 of a
rip-off.
penny. That's what 3,000th
You
would
cut
be.
a penny.
But anywho, what I'm saying is if we have any numbers past the 100th place in our answer, right? This is a dollar answer. Can you pay $20 and 990 cents and 8/10 of a cent? That doesn't make any sense. And so we're just going to go ahead and round. And so we'll just stop at the 1,000th place, and we know to stop at the 1,000th place because we're not going to go any further for money because we can't. There's no less. We only use pennies, right? And we're going to round to the 100th place, the nearest cent. That's what people say when they say round to the nearest cent. That means round to the 100th place because there's 100 cents in a penny. There's 100 cents in a dollar, and also cent means 100, right? Okay, and so we look at the number to the right, and so that's an 8, and so the 8 means we're going to round the 0 up, and so our answer is rounded to what? Shout it out, students.
Rounded to $20.91.
Yes, $20.91. Perfect. So you say, so the first question is, were they able to share the cost equally? They cannot.
Not.
Cannot.
Why does cannot not have a space?
It's just a compound word. Cannot share the cost because no one cannot share the cost equally, I'll say. Or you could even say perfectly equally. Because no one can pay, and how much were they gonna have to pay? 8 out of 10. 8 thousandths is 8 out of 10 of a penny. Yes, I'd like to purchase one thing with 8 out of 10. Well, 8 out of 10 of a penny, please. I only have 8 out of 10 pennies. I only have 8/10 of a penny. And even when you guys think, if I say 8/10 of a penny, 8/10 means 8 out of 10, right? Okay, so they cannot share because and then the other question is, how much should each person pay? Each person, and we had to approximate or round our answer, right?
To $20.91.
Absolutely good.
But,
You
like,
had to say
Mr.
about
Berry,
each person. Yep.
What did they order that cost $125?
Probably dim sum.
20 pizzas?
Dim
Probably
sum's pretty
20
expensive.
lobsters.
Each person, 20
Mr.
lobsters.
Shrimp?
That might be a lot. Each person pays about, yep, keyword about, very important that you included that, about
About.
$20.91. Because if you don't say about, then that person should be able to take your number and use it to land on the moon. If they can't use your number to land on the moon, then it's an about number.
You're 1/10 off.
Oh, yeah, you're 1/10
Now we're all gonna die.
Now we're gonna lose $3 billion to our rover because you were 1/10 off and you forgot to use the word about, and it's all your fault.
No,
Make
because
sure to use the word about or you're gonna break your probe.
didn't say 20.9111111.
Absolutely. So if all the students want, they could go ahead and wave bye to the video if they want. Goodbye, Virtual Berry. Bye.
Bye.